final exam project.
Hypothesis. Since our school is considering the implementation of a one-to-one computing initiative, we surveyed the students at MFL Marmac High School. We asked them if they oppose the one-to-one computing initiative. Before conducting the survey, we hypothesized less than 40% of students oppose this initiative.
Our sample size. To determine the approximate sample size, we use the equation n equals zx over 2 squared times p hat times 1 minus p hat all over e squared. We decided to use the confidence level of 95%, so we used a 0.05 margin of error and a z-score of 1.645. The sample percentage p hat used was 0.5. After using the previous equation, we found out we needed a sample size of 271 students. Surveying this many subjects was not feasible because of the small number of students in our high school. So our teacher told us to survey between 75 and 100 students.
Sampling. To ensure we obtained a simple random sample, we drew 5 names out of a hat containing the names of high school advisors. During advisory periods on January 6th and 7th of 2011, we visited the classes to ask them if they opposed the one-to-one computing initiative. The results are as follows. Mrs. Wilbert's senior class advisory, 10 out of 18. Mrs. Shellhorn's advisory, 1 out of 18. Mrs. Biedekofer's advisory, 0 out of 18. Mr. Langhuse's advisory, 0 out of 18. And Mrs. Ford's advisory, 0 out of 18.
Confounding variables. Confounding variables are factors which possibly after the results of a survey. Below are a few confounding variables in this survey. Many underclassmen participated in this survey. One reason for their support of the one-to-one computing initiative could have been their experience in classes where technology is taught or is already used daily. Seniors expressed stronger opinions because they are more educated about the program. This excess knowledge came from the attending high school board meetings where one-to-one was discussed.
Our claim was less than 40% of high school students at MFL Marmac opposed the one-to-one computing initiative. The opposite of our claim was at least 40% of high school students at MFL Marmac opposed the one-to-one computing initiative.
Importance of stating the claim. First, we need to state the claim clearly so we know the specific hypothesis we are testing. What are we testing? What values should we use to test this claim? Second, we must be reminded of the claim in order to identify our null and alternative hypothesis. Third, we should present both possibilities. To include both sides of the claim, we must state the probability is less than 40% and of greater or equal to 40%.
Hypotheses. Our null hypothesis, which must include an equal sign, was HO equals P hat is greater than or equal to 0.40. Our null hypothesis, the percentage of students who oppose the one-to-one computing initiative is greater than or equal to 40%. Our alternate hypothesis, which was our claim, ended up being P is less than 0.40. Our alternate hypothesis states that less than 40% of high school students oppose this initiative.
Testing the hypothesis. When we are testing the claim, we are testing to see if the null hypothesis is true. Once again, we use 95% confidence level or 0.05 significance level, and therefore use a critical z-score value of -1.645 to test our hypothesis. Next, we draw a normal distribution curve and place the -1.645 value on it. We shade the area to the right of that value because the null hypothesis asks us to look for values greater than or equal to this.
Testing the hypotheses. To find our critical point, we use the following equation, where P hat is the percentage from the sample, P is the tested percentage, Q is 1 minus P, and N is the population of the sample. In our sample, P hat which turns out to be 0.1264. Our P is 0.4, our Q is 0.6, and our sample size N equals 87. Once we do the following equation, we get negative 5.2092.
Testing the hypotheses continued. Before we figured out the critical value was negative 5.2092. Now we place this number on our curve. If it lands in the shaded area, the null hypothesis is supported. If it falls outside the shaded area, our alternate hypothesis, our claim, is supported. Since the number is outside the shaded region, the null hypothesis is rejected.
Conclusion. Our claim, the alternate hypothesis, is supported by our test. So, less than 40% of students oppose the one-to-one computing initiative. In the end, most of the students either expressed no opinion or favored the initiative.